Good morning, participants. I, Jamingo Singh, founder and CEO at Rectron and CTO at Stockity and Mass Energy. I welcome all the participants in our session 5 on FDP program, Artificial Intelligence and Data Analytics with Matlab. And in this session, we'll be basically learning the fundamental concepts of machine learning and deep learning. This session will be mostly dedicated to machine learning part. And from tomorrow onward, we will be looking into the deep learning part. So in this session, we will be understanding the key component also like what key component of MATLAB can be used for machine learning model development and understand all different types of machine learning model based algorithm and understand the performance and limitation of AI and ML algorithm. Okay, if you look at to the domain of artificial intelligence, machine learning, and deep learning, then artificial intelligence covers a broader umbrella in which machine learning and deep learning are its subset. Okay, because artificial intelligence deploy all the features of machine learning also, in which we have to provide the features, and then the computer is able to understand the thing. Okay, and in deep learning, we just have to provide the data and the feature are extracted by the machine itself. We don't have to give the feature. Okay, and there is one more method in which we create the rules. Okay, so it deploy all the three, and if any application is using all the three methods, then it will come under the category of artificial intelligence. So that is a broader umbrella in which it uses all the applications of all these individual uh, elements. So the question arises, after all, why we require or when we require the machine learning model and when we will require the deep learning model. Okay, so that we will understand now. See, I take one example here that I have to create a machine that can distinguish between a fat person versus a thin person or a normal person. Okay, then in order to solve this simple problem, I can take many approach. And first approach, I can create my own rule. Okay, and what I will do based upon the image which I have, I can create some feature. Say one feature is the aspect ratio of the image. Okay, so what I will do here, I'll calculate the height of this image and the width of the person. Okay, so and I will take the height by width ratio, and in this way I will create a table. Okay, so obviously the thin person will have a higher aspect ratio compared to a fat person. Okay, and based upon it I can create a threshold rule, like if the aspect ratio, okay, is greater than say zero point 0.6, then I will call that person a normal person. Okay, or else if the person aspect ratio is below 0.4, then I will call that person a fat person. Okay, so here I have created my own rule, though the problem was very simple. But now try to correlate this thing uh, with the plant species. Okay, where you have a different types of plant leaves, and based upon the leaf you want to predict like which family of plant it belong. Okay, so there this simple aspect ratio won't be very helpful. Okay, and we will require more number of feature. So sometimes it becomes very difficult for a human to create rules. Okay, or whatever rule he can think of is not suitable enough to predict the right answer. And sometimes it is also very difficult in order to extract a feature also, like in this case we can have one feature that is only the aspect ratio, and what can be the other feature in which we can relate, maybe body mass index of the person, that can also be the second feature. So like that there are only limited possibilities in which we can extract by our own effort a limited number of features only. Okay, body mass index can be our other feature. Okay, so here in this example, we were like able to take only these two features by our own effort. But if we correlate to the plant species, then it will be a hell lot of like hectic work in order to extract the desired number of features in which I can train my machine. Okay, so there, what we do, we go for a deep learning model in which we just provide ample amount of data to machine, and the machine is able to extract the feature by its own. We don't give like what it should extract the feature. So if we are providing the feature and machine is learning to recognize automatically, then it will come under the domain of machine learning. Okay, it will come under this category where humans provide the feature information, not the rules. Okay, the rules like machine will automatically assign like based to what it is performing well. And in deep learning, we don't provide any feature, rather we only provide raw data, and that in bulk amount, in very high amount. So raw data is almost greater than 1,000 per set, and here the raw data is very less, and we can easily extract the feature out of it. So, and in artificial intelligence, it also covers one more domain, that is our created own rules. Okay, our created rules. So it deploys all the three aspects: our created own rules also, machine learning model also, and deep learning model also. Uh, my audio is not audible to some participants. Am I
Yeah, it is
audible?
audible to me.
Yes, sir.
It is audible to me.
Yes, sir. It is clear, sir. Sound is good, sir.
Okay, okay.
Maybe those who have
Few
written, they have
participants.
internet problem.
Yeah.
Slow internet.
Okay, okay. Anurag sir and Sangeeta ma'am, like now your problem is resolved, or still you are not able to hear anything? Okay, okay. We will continue then. Now, where we should use machine learning or deep learning model, this thing also is very much essential to understand before developing a model. Okay, so as I said, there are some situation in our life that where uh, we cannot create a sufficient good rule to recognize something. And say, take one example, that is a handwriting. Because we all are teachers and we are all into a teaching background, so we have encountered like a different handwriting of the students, and sometimes the handwriting of student is so much difficult to understand. Okay, so there also we cannot have a very well defined rule which can recognize all these things. So in that case also, where the rule is too complex to design, there also we can use a deep learning model to recognize what exactly the, as per the handwriting, what exactly the word or sentence is. Or in terms of speech also, like say we Indians like speak in a more English kind of a accent. Okay, compared to the foreign English, so the accent is very different, right? So there also, if you go from state to state also, there also some accent will change. Okay, so in this case also, when there is too much variation in the input data, there also we can deploy a deep learning or machine learning model. Okay, see, the other task is which is continuously changing its nature. Say the fraud detection. Earlier, the email, if you take the example of the phishing attack or the spam attack on the email, they were using some different kinds of a pattern. Say in email, they used to write offer, grab this offer, urgent, hurry up. Like these words are there, but now it is more natural way they are approaching. So here also uh, the input is changing and it is more dynamic in nature. So to track all this information also, or the pattern, we used to, we can deploy a machine learning or deep learning model. And the third one is like related to forecasting based upon stock trend, shopping pattern, taste, and what people likes. That also changes, because as we know, the fashion world, if you look at, that too changes continuously. Like what was the trend in 1990s, like what clothes people used to wear, and now what clothes they usually like. Okay, what kind of song they used to hear earlier, and what kind of song now the generation is listening. Okay, so the taste and the like is also changing. So in order to recognize all this thing and to get a hidden information, or to know the exact pattern in which it is going, in there also we can use deep learning model or machine learning. And why we require all this thing? In order to understand the market, so that we can increase our sales or give better performance uh, for that purpose. Yeah. Hello. Okay. Uh, yeah. So I hope this is clear, like what is the application of machine learning and deep learning and where we require it most. Now we'll go to next slide. So after all, what is machine learning? So basically, machine learning teaches the computer what comes naturally to any human being or any animal. That is, we both are able to learn from our experience. Okay, so from child, like if somebody wants to tell a child that how a table it look like, then throughout his span, like in 5 or 6 years, he able to see like lot many types of different chair, different tables, and he can, from his experience, he can correlate. And then when the new kind of a furniture comes which has a pattern similar to like a table, he can easily recognize, okay, what exactly it is. Okay, so in nature also we learn from our experience. So we are replicating the same thing in machine learning also, like providing the data so that the machine learning can deploy its own algorithm. Okay, and do some computation which directly take the information from the data without relying on a predetermined equation as model. So here, without relying on predetermined equation as a model, is related to the first case which I was talking, like if condition I'm writing with some threshold. Okay, so that it don't rely any rules from your end. Rather, if you give the data, it will extract the feature, and as per the feature, it can categorize it. Okay, so that is basically a machine learning is a approach where we uh, make a machine to learn from the data, taking data as experience. So that's why we arrange data in terms of row and column, where row represents the observation or experience, different experience point. Okay. So here one example, uh, a family goes to a foreign country where the text they are not able to recognize, but is in foreign language. So they take one AI based application and it convert the text. So similarly, we can do with the face, music also. So basically, it deploys a neural network, which is a kind of a basic element or a building block of any machine learning model or any deep learning model. Okay, so as like in our brain we have neurons, in same way in machine also we are making neurons in such a way that whatever data will pass, they will assign some weightage score to it. Okay, and as per the score, that same information will be shared with the other neurons, and through the activation function, which we're going to see in more depth in tomorrow's session, that activation function will decide whether or not that neuron can transmit the information to the other layer of neurons or not. Okay, so imagine this case with our own brain. Sometime whenever we see an object, we feel very happy. Okay, so happiness is a kind of a different section in our brain which is very sensitive to particular things. Okay, because only some things in our life gives us pleasure, right? And there are some things which irritate us, right? So it's all depend upon the data, and there in brain there are some neurons which are sensitive to those objects, that creates emotion in our brain. So similarly, same approach we are taking in machines also, like we are creating different neurons which are sensitive to some or particular pattern of the object. Okay, and they will be like, once they get that pattern, they will be giving more value. Okay, and other neurons which are insensitive to that pattern, they won't be generating any values. Okay, so this way it just cluster one layer to another layer, and the information passes till the last layer, where the data only depend upon in which category we want. Okay, so that we will see in more detail in tomorrow's session. Just here we are getting the a broader understanding of it. So data here is same to the experience, and the neural is the kind of a neural computation or the mapping it does in order to give a desired output. If the output is not right, then again it will keep on iterating all these weight and biases. Okay, so whatever this blue color disk you are saying, these are all neurons uh, whose value will be changed or hyper tuned as per the output. So here we are creating one neural network which has to distinguish between three objects. Say first object is square, other object is circle, and the third object is a triangle. So this neural network will think that in all universe there are only three objects only. Okay, one object can be square, other object can be come under the family of circle, and the other objects can come under the family of a triangle. So there are only three families. Okay, like as we divide the species into male and female, so similarly here also, like neurons are learning only three patterns. So whatever information you will pass, they will try to categorize, give the output only in terms of uh, square, circle, and triangle. So in the last layer, we have to keep the same number of output which we want. Okay. So the first layer depends upon the size of the input, and the other layer which you are seeing, that are called the hidden layers. So that also we'll see in deep, like later on. So first layer is always called the input layer, and its size is always proportional to the norm normal or normalized size of the input. So this circle is made up of 28 by 28 pixel. So the first layer of this neuron will be 28 into 20, 28, that will be equal to 784. So here you can see that each pixel data is assigned to each neurons, and these neurons are sensitive to some particular pattern, and accordingly they will generate some values. So neuron one layer is connected to the neuron of other layer, and they assign some weight to the channel, and the next neuron, what amount of data it will acquire, it depends upon the weightage and the data. So x1 will be holding the data of the pixel, it is multiplied to 0.8 weight. Okay, similarly the data coming to the this neuron is from x3, but in general what happens, one neuron will transmit parallelly all the data to the other neuron. So it is just a very simple description, like visual simulation. So here, like we have shown, only one neuron is giving data to only say one or two here. Okay, like X3 is giving data to the first and the third one. Okay, but in general, what happens? The same neuron will be parallelly transmitting the data. Okay. Oh, sorry. 1 minute. Yeah. Okay. Yeah. So after this, we assign some offset, which is also called bias to the net sum of the neurons, and after this it goes to a activation function where it decide whether the neuron will participate into the information sharing or not. And how it decide, it check like is the value is close to 1 or it is close to 0. If it is close to 1, then only it will be allowed to transmit the data to other neurons in the subsequent other layer. Okay, but if its value is close to 0, then it will be turned off. Okay, so like that. So here the yellow blinking neurons which you can see are the activated neurons because they have a higher value, and the off neurons which you can see like B2 and B5, because they have very low value 0.1 and 0.1, so they are not participating. So this way the information goes on, and it finally has to give more weightage to the square, circle, because the input is circle. But in the first iteration, then it may not give a higher weightage to circle. So this, it will go to back propagation, try to retune all this weight and biasing so that the error minimizes. So here we can see that it gives a wrong prediction. Now we will calculate the error. What is happening? Yeah. So here, because we know the output should be 0.4, should be circle. So the circle should have a higher value output. So it will be subtracted from the logic table, okay, where circle will be 1 and rest a square and triangle will be 0. And from this, a difference will be calculated. So the circle difference you can see is positive 0.6. So this should be very close to 1, and the other z errors which are negative, that should be minimized. It should be close to 0. So our back propagation will start, and it will start tuning the hyperparameters which are weight and biases, and it will do until it achieves the less error configuration. So this process goes in training. So in training, it keeps on forward and backward propagation until it reaches the minimum error. So that's why it can take minutes, an hour also, to train on the raw data which you are providing to the machine. So now we are looking at some application, say facial recognition using smartphone, in which it just capture your face image and try to recognize who the person is. Forecasting of data, say any financial market trend or rainfall or wind velocity. Music composition also, like you can get it out. So these are different applications of a neural network. Now basically any machine learning model or a deep learning model is divided into these categories. So machine learning model is broadly divided into two categories. The first is called the unsupervised learning, in which we lump the raw data into segments or clustering. Okay, and here we only provide the input. There is no output. And the next category is called the supervised learning, where we provide both data, the input data also, and with respect to this input data, what should be the output in order that the machine can learn itself. And this way, their supervised learning split into again two categories. First is the classification category, in which it will broadly categorize the output in some categorical data or a group or a class family name. Okay, or it can give a exact value in terms of, say, power energy demand, where it can forecast like tomorrow how much power demand can be there. So there we require a particular value, not a high or low or moderate kind of a segment. Okay. So all such problem where you require a exact number, that will go under the regression category, and LSTM is an advanced version of this regression category only, which gives more accurate result in terms of time series data. Okay. And classification, as what we have like taking the example in the first few classes of a flower family, or a patient that who is normal patient, or a person who is having cancer, like that. So all those data will go under the classification model, supervised learning and classification model. Okay. So any doubt up to here? So this is a kind of a example which we can see, like what is the time series data. So in image also, like there can be some cases in which a particular sequence of data, if it is carried out, like say this is a Surya Namaskar Asan pose. So if I give a particular time series data to a machine, then it can predict me, okay, what can be the other output, okay, in terms of image. So it won't be giving any random, rather we have to give a sequential data, and so it can predict. And in finance example also, like on daily basis we have the data, on daily basis we have the data of say weather, so we can easily predict the weather for tomorrow because we have trained our model on a definite time series data. Okay. So supervised learning, as I said, it is broadly classified into two categories. The first category is called the classification category. Uh, and we will take some example, like in which cases we can use. Like for example, if we have a lot of email collection, okay, and we want to categorize the email based upon like which is a genuine email or which is a spam. So here also we have a fixed category. Okay, we have a two category in which we want to know like which is a normal email or which is a defective email or a spam or a potentially hazardous email. Okay, so here again it is a kind of a classification example only. Then whether in a patient we want to know like whether that MR scan or CT MR scan is a kind of a tumor of size small, medium or large, so that will also go under the classification category. So classification model are trained basically on to classify into some categories, and application can be image based or say sentimental analysis on text also will go under the classification, in which we want to know like whether the person is in angry mood, happy mood, confident, or as per the classification. So all these types of model will go under the classification category. Okay. And in regression, as we have discussed, that all the time series data we provide in a regression model so as to know the forecasting in terms of values. Say one example is of the electrical demand, okay, and the change in temperature that is related to weather forecasting. Application include stock market or handwriting recognition or acoustic signal processing. So here we require in terms of values, so we use a regression model. Any doubt up to here in understanding any basics related to machine learning, deep learning, like where we use, what is the difference between machine and deep learning? Because generally, like it create a lot of confusion in many people, like what exactly is machine learning and what exactly is deep learning. Sir, in neural network, the weightage like 0.8 and 0.2 is multiplied with the input layer, no, correct? Yes. Whether that value is given by ourselves or it takes by default. No, it takes by default. Okay, we don't provide. We just provide the data and we just click on the train, and machine will only adjust all those values. So financial crisis prediction will come under classification or a regression. It will come under regression if you want to know the value in terms of like say L&T stock. If you are saying then it is quite low today, so it will go for this one category only, regression only. But yeah, you can classify into two categories also, like whether it is uptrend or downtrend. So in that case, you can put the same model in classification category also. But regression will give you the confidence also, like how much risk you can take. So in that way, a regression model will be more effective than a classification model. Sir, any kind of prediction like anomalies in a network is in a network classification and regression. Ma'am, what exactly your problem? I didn't able to understand it properly. Manorma, a doubt from participant Manorma.
Good morning, sir.
Good morning, ma'am.
My doubt is, suppose any kind of network anomalies we are going to find. So whether it is a classification or it is a regression.
Anomalies, you mean any technical kind of a glitch in network, right?
Yeah, any error or suppose
Any error.
hmm.
Okay. So in that case, ma'am, you want to classify into a category like a faulty network or a normal network, like in that way. It will go under classification only. So classification, you can treat it like a general group name you are giving. Okay, man, a male, a female, flower or animal. So these are our more general group names. Okay.
Okay.
So if we take a finance example, say, okay, so 1.1 and 1.2, okay, like I will
Hmm.
directly show it uh, with example, so it will give a more clear understanding.
Okay. Sir.
Okay, so here all the participant, I think they can see the graph trend. Okay, and as we know that yellow line is a moving average of 100 days. Okay, so here we can see the yellow line is in going in up direction. Okay, so for me, if I'm doing a classification model here, then it will only tell me it is the uptrend. But whether this uptrend is very steep or very shallow in nature, that I cannot have it. Okay, because it will just broadly divide into two category, whether it is uptrend or a downtrend. Okay, but if I implement this thing with regression model, then here regression model will give me an exact number, and with that number I can compare like whether the next day I can have a spike or I can have a like rise, a steep rise or a shallow rise. Okay, so like that it can give me a more insight information in terms of number. But say if I want to classify animal in terms of some few species, so there I don't want to deal with number. Rather, I just want to know, okay, if whether it is German Shepherd or Labrador, they both belong to a dog family only. So I want to know, okay, my machine should able to predict that whether that four-leg animal is a belong to cat family, dog family, or a cow family, like that. Okay, so this way it depends. Sir, in a current situation project like automatic
Hello.
detection of people wearing mask or not mask, it is a classification problem. So it will come under which category? Machine learning or deep learning? We can develop that model with both, sir. With machine learning also and deep learning also. Uh, yes, sir. Somebody was asking the question.
Hello, sir. Good morning, sir.
Good morning, sir. Yes, sir. Tell me.
Hello.
Yes, sir. Yes, sir. I can hear you, sir.
Sir, my
Tell me.
question is that I can use this model or protocol during this patient detection. Either he is suffering with cancer or not.
Okay.
Through this model, this presentation, I can detect. Na?
Yes, sir. Yes,
Can I
sir.
detect this one?
Correct, sir. You can detect, but I want to know like what kind of data you are passing. The data is in form of say image, like say some X-ray or CT
The
MR
from
scan or some
correct.
spreadsheet you have.
Yeah, correct. I am working on the data set. Data set means the patient data set, whether they are suffering with a fever or any kind of
Okay.
disease. Then it can detect
Okay.
that it
Yeah,
can
yeah.
detect through
It can.
with the help of this data set. We can
Correct.
make the
Yeah, yeah.
recognized detection the whether they
Correct,
is
sir.
suffering with cancer or not.
Correct, sir. It is
Okay,
possible
sir.
with
Thank you.
classification model. We can do it. Yes, sir.
Classification model. Correct, sir.
Yes.
Correct, sir. Thank you, sir. Thank you.
Sir, this is silly question, maybe, but I haven't understood the question. Is mostly probable for the face recognition will be using programming where comes the question of handwriting. The first and the PowerPoint which are the presentation.
Excuse me, sir.
Yes, sir.
So there is one doubt.
A
If I have a spectrum data,
a spectrum
like
data. Okay.
it will give me the signal values and
Okay.
for different frequencies.
Correct.
Like suppose I have a range of frequency from 700 megahertz to say 3 gigahertz,
Okay.
and at a resolution of 200 kilohertz, I am making the measurement through spectrum analyzer.
Okay.
And for each frequency point I am getting a signal power value in dB,
Okay.
and if I so I can apply a threshold to detect whether it is signal or noise, and then I can get a data wherein for each frequency I can understand whether the signal was present or not.
Okay.
So if I have such a historical data set with
Okay.
me, which is very huge data, because when I make a measurement of 24 hours,
Mm-hmm.
for each 2.5 minute or 3 minute, the CSV file is generated,
Mm-hmm.
and it has a very huge data. So many CSV files are generated per day.
Mm-hmm.
So how can I? Which approach should I follow for this, and how can I go ahead for predicting? Like in future, if I want to predict the occupancy state, whether this channel is occupied or not, or whether for this particular frequency the band will be available or not.
Mm-hmm.
So basically, with regards to spectrum prediction,
Mm-hmm.
so how can I use this
Okay.
technique?
See, sir, in your case, what you can do, because you have a lot of data, say spectrum data, so obviously you have a lot of data in spreadsheet. So first, what you do some feature extraction in which you reduce all the dimension of the data and just create a smaller table with relevant feature, say number of like higher frequency, like measurement you are having, how many times they
Okay,
are occurring. So like this, you create a feature table out of the 2.5 minute like what spreadsheet you are making. Okay,
okay,
so this data you keep on arranging it, and it is good that you have a lot of data. So your machine learning model, because in this case a classification model will be better for you, and it can learn
okay.
more efficiently. So next time, the moment you pass any sample data to it, it will quickly tell you like it will go under which category. So you have
So
to
it
do
will
the
be
dimension reduction first, and then go for.
okay. So
Yes, sir.
basically, it will be supervised learning
Yes, sir. Supervised learning under classification category.
under classification. Okay, thank you, sir.
Priyanka ma'am has asked this question, so this, but I haven't understood the question is. Most
Good
probably
morning,
for
sir.
face recognition, will be using programming. Where comes the question of handwriting?
Good
The
morning, sir.
first, okay, yes, sir.
Sir, regarding one doubt related to supervised learning techniques,
Okay,
sir, I am having the data set related to electroencephalogram signal. So, which machine learning or deep learning is suitable for processing that biomedical signals, sir, like ECG, EEG, and EMG signals?
sir. If you have lot of data, then I'll better recommend you to go for deep learning. Okay,
Sir.
but if you have very less amount of data, then we have to go for machine learning, in which we have to create like feature extraction from the data.
Okay,
Okay.
sir. And deep learning, sir, it's automatically whenever we are going to input the data,
Okay.
that raw data. So is it necessary to extract features, or automatically that model is extract the features?
Yeah, so that is the only good thing about deep learning. You don't have to do anything regarding feature extraction. Just you have to give a data and it will extract the feature automatically. But what feature it will extract, you cannot predict. Okay, because the feature can be 100 feature, like say for the example of the fat man example which I have taken just in the beginning. 1 minute. This one example, uh,
Is
I'll delete. So here, if I put into deep learning model, then in deep learning, it can extract 100 of feature out of the same pictures. But that is not possible from our end, okay? Because we able to give a more relevant feature, okay? Maybe with deep learning, the other feature won't be playing that much role, but it doesn't matter to it because it deals in a size of matrix. Say I have a size of 2 by 2 matrix. So there I know that all the possible arrangement of a number in a 2 by 2, that is 4 number I have to set. And if I've given the constraint that I have to either fit 0 or 1 to add to each places, then I can have 2 into 10, 2 into power 4, that is 2, 4, 8, 16. 16 number of arrangement. So 16 number of filter it can create. Okay. So
yes.
it is up. Yeah. So that is the, like if you have a lot of data, then better go for deep learning.
Okay, sir. Thank you, sir.
Okay. A doubt from Priyanka, ma'am. Ma'am, see, for facial recognition, we can go for both. That is the coding method also, machine learning model also, and a deep learning model also. So all these three I will discuss tomorrow. Like I'll take an example and I will discuss with all the three methods. Right. Like manually we'll be doing PCA based reduction while coding everything. So that way we'll be recognizing and we'll be using machine learning model. Maybe I don't know which model will give us the best result, but Matlab will tell, like in this case, which model can give me the better result. And later on, I'll use deep learning model, which is convolution neural network, CNN, 2-dimension. And with that, I can, without writing much line of code, I can easily train a model. Sir, for the
Sir,
detection of, yes, sir.
sir, suppose that the data set is very small.
Okay.
So we cannot go for deep learning?
Yes, sir. In that case, you cannot go for deep learning because the efficiency will be very poor. Why machine learning and deep learning slides? First point. See, because machine learning and deep learning share a lot of feature with each other. Just there is only one difference that differentiate whether that learning model is a machine learning or whether that model is a deep learning one. And that feature is, like in machine learning, we provide feature, but in deep learning, we don't provide feature. We just provide data. Rest the technique will be same. In deep learning also we have supervised learning based upon classification. That is the example which I'm discussing right as said. The CNN 2D, that is a deep learning model based upon supervised learning and it goes under classification model. And then we have LSTM, long short-term memory, that is under supervised learning and it goes under regression, advanced regression technique. Liver segmentation scan will come under unsupervised learning. Sir, if you, Sangeeta, sorry, okay. Ma'am, if you have the data, just the image data, and you don't know whether it belongs to a infected case or a normal case, in that case, you can go for unsupervised because in unsupervised, the difference between unsupervised and supervised is that in case of unsupervised, we don't tell machine what is the output. We just give the data. Let me correlate this example with a real case. Say suppose uh, you don't know about cricket, okay, and you don't know any name of the athlete also there, okay, any player, but somebody gives you a spreadsheet without say their original name, and the code is just a serial number 1 2 3 4 5 6 7 8 9 10. With this serial number, they have given two features, just two feature, and one is the score and the other is the wicket. Okay, now getting this thing, you don't know like which one you will call a player, a batsman, or a bowler. Okay, so what you will do, you will put this model into a unsupervised learning, a clustering model, and there machine will cluster all the data. Okay, and it can easily separate and populate clusters. So one cluster will be representing the player which have a score in terms of batting. Okay, like, and the other score will be related to the player which have like more wickets and less run, like that. So machine can automatically filter out and segregate and make a lump or a cluster in a spatial distribution. Okay, and it won't going to tell you that yes, this cluster is called batsman or whether this cluster is called wicket. It will just cluster you and give you that, see, there are only two clusters, cluster 1 and cluster 2, and it is up to you what name you want to give. Example can be same which we will take in the present session also, like the flower setosa, and that one in which we'll remove the output name, and just depending upon the petal length ratio, aspect ratio, we will see how machine are able to segregate from the input. So that is the only difference in unsupervised learning compared to the supervised one. Like supervised is like if you have a child, then you are telling him, see how to write a look like this, so you have to write it like this. So that is a supervised, because you already know the output. And an unsupervised, it is like he is only trying to write it, whether it is right or wrong, it doesn't matter, he's just writing something. Okay, and trying to mimic like how the art is. So that way. Life segmenter. Sir, is deep learning is equal to big data plus neural network? Yes, sir. Absolutely right. Deep learning is related to big data and neural network. Sir, kindly repeat the wrong prediction in the neural network. Okay, you're talking about the back propagation technique. Okay, I'll repeat that also. Can we use add rule in deep learning? Sir, in deep learning, we cannot create any rules. The rules and the feature are will be taken by the machine only. The machine will be keep on optimizing itself or do the iteration until it able to reduce the error. Okay, and how we are calculating the error? I'll repeat simple neural video which we have just seen. So that way we can correlate. Okay, so once again play this video. So here the target was 1 minute. We have an input image, say a square, circle, and rectangle. Out of this, if I pass circle, so that circle image comes under a size of 28 pixel by 28 pixel. So the neuron has to assign some weightage, some biasing, so that the output, which you can see, there are only three neurons. Okay, so the first neuron is directly correlated to square. So if it is a square, the input is square, so the output neuron 2 gives a higher value that is close to 1. Okay, but right now we can see that we have the input image which is circle. So the neuron network should arrange their weightage and bias in such a way that they should give maximum value to circle and least value to triangle and square. Okay, so for this they required forward propagation also and back propagation also technique in order to tune it. So first neuron reading all the pixel value gives the information to the second layer. In second layer, they will assign particular weight and bias, and activation function is not shown in this simulation video, but there is one activation function which decides like which neuron will be activated to give information to other layer or not. Okay, and that I've already explained, like on what basis activation factor decide. So activation factor checks for the value, like if the neuron is having the value close to 1, then they will be activated. If any neuron will having value close to 0, they will be deactivated from the network. So this is called forward propagation if the cycle goes from input to the output. Okay. So obviously, because all the weight and bias are assigned a random number, so there is high chances that it cannot give a true result in the first attempt only. Okay, so it has to keep on iterating itself until the error is minimized. So what approach it is taking to know the intensity of error? Okay, so yeah, what happened? Yeah. So we can see here in this example that though the input image was circle, but it is giving highest probability or highest weightage or uh, to this square, okay, which is 0.5. So the error amplitude now we will calculate because we know it should be circle. So for circle, we will assign 1 as the true output, and for a square and triangle, we will assign 0 as a true output, okay, and we will take a difference. So here you can see we have taken the actual output, okay. So actual output is the, like in supervised, as I said, we already give the output to the machine. So it will be compared with the actual output, and here it can easily see that there is a difference. So it will calculate now the error part. So here we have seen, okay, what is the error? So 0 minus whatever output of the machine is, so 0.5, so it is minus 0.5. The error amplitude is high, and in terms of circle, the error amplitude is something 0.6. So this value should be close to 0 in terms of square and triangle. Okay, so this, to achieve this one, it can adopt say gradient descent method, in which it will be changing the value and seeing, okay, whether the error is decreasing or not. Okay, like what we have discussed earlier, cup shape example in a graph. So it will be keep on checking because the target is to minimize the error as much as possible. Okay. So now it will initiate forward, or sorry, backward propagation technique, in which it will be changing the value from last layer to the beginning first layer, and it will check again through forward propagation, like what is the value it is able to achieve. And this method keeps on iterating until, sorry, until it able to achieve the best result. So here we can see, okay, now the error intensity is quite low. It is minus 0.04. So now because it is giving more weightage to the circle part, so now we can stop the training. Okay. So there are various criteria to stop the training, like they check that is the inbuilt code. If the error is less than third significant figure value, that case the machine will stop the training automatically. Okay, so now I'll take a 5-minute break, and after this I'll continue. Okay, so Yeah, now we will continue. So any doubt up to here, understanding any concept like what is machine learning, deep learning, and all these techniques? Okay. So by the way, I'll show you the real picture also, so that in order to clear.
No, sir.
Yes, sir. Yes, sir.
No, it is clear, sir. It is
Okay.
clear, sir. It is clear.
Thank you.
Absolutely clear.
Okay. Okay. Just for this one, what I just want to keep on nutrition discard. Okay. Actually, in real, each neuron, as I said, it like this slide is meant for tomorrow, but just to clear the understanding, because in that simulation it was showing some neurons is giving to some neurons only, but that doesn't happen. Each neuron will be sharing the information to all other neurons. Okay, so that is the actual picture. But there, in order to get a simulation or a broader understanding, we used that part. Okay, so it was like this. And so we'll continue with this one. Okay. So now, what is the working approach in order to develop a trained model based upon machine learning or deep learning? In both cases, it is same. There is no difference. First, we have to access the data and then pre-process the data. This is the main critical step, and it is like if you have a vehicle, then if you feed a good fuel to it, your vehicle will perform very well, right? So similarly, in any training model also, if your data quality is good enough, okay, then obviously the model will perform very well. Okay, so same thing happens here also. So that's why a pre-processing plays a important, very crucial role in developing the whole AI or deep learning model or machine learning. So first two step, we are now very much skilled in order to make any kind of data and pre-process it, and then derive the feature. It totally depend upon our course subject knowledge intensity, because based upon it, like the person who is like biologist, so he can like better able to extract or assign some feature if he is doing for machine learning than compared to a mechanical engineering person or a civil engineering person. A civil engineering person can better assign feature properties to the data related to bridges and structures. So it totally depend upon the core subject of yours. Then the other part, which is training the model, and then like what we have seen, the forward and the back propagation, it just continues till it achieves the best model. Okay, and once that model is developed, then it is up to us, like we can use it as a kind of a function, or we can deploy the entire model into a machine to use it on a real time basis. So all this thing we will see, the integration to a real application we will see on the last day. Okay, because there we will develop one exe out of like whatever work we have done so far, and we will use as a standalone application. So this is a general feature extraction technique, like it, as in the point 3, like it is mentioned that we have to derive some feature for a machine learning model. Okay, for deep learning model that is not required, but for a yes, for a machine learning model. So this is a generalized technique which are generally people use for extracting the information from a sensor. Say I have taken one example in the previous case of heartbeat sensor. Okay, so there I just want to know the peaks, so that the peak will be directly proportional to the number of heartbeat. Okay, so there can be other method also, like pulse and transition matrix, spectral measurement. Then for images, text and video, there can be bag of visual words, histogram gradient, minimum eigenvalue, edge detection. And similarly with the transactional data, we have timestamp decomposition and aggregate value calculation. So these are just general. Apart from this also, we can have different techniques which can be very effective in training the model. Can pre-processing step be automated? Yes, it can be automated. Like we have already seen this one, like when I was dealing with image processing. So whatever functions we were creating, those functions, if you arrange in a sequence manner, then they can automate it. Like we have seen the example of batch image processing also, like where you create one function and it will entirely run on the complete folder itself, and there it can like pre-process all the data automatically. Yes, it will require information from your end, like when you want to pre-process. So that if you give a command, then computer can do it, like if everything you have linked up, like from which folder it has to extract the information. Which feature extraction technique suitable for text or numeric data? Again, it depend upon your core area, like which area you are dealing with. Say suppose if it is a kind of a finance problem, then there we deal with moving average. This one, yes, the one is the moving average, then the other one is exponential moving average, then convergence and divergence, MACD, like moving average, convergence and divergence factor. So it totally depend upon your core area, and based off it you can like decide, okay, like what should be the feature. As someone in the participant was asking about the spectral data, so there he might be interested in the number of higher frequency found in the data set, okay, or the high energy peak. So in that way it totally depend upon your core subject. Can we use ResNet and AlexNet as it is just for the classification of image, or it is just an architecture? Okay, ResNet and AlexNet, they are both deep learning architecture meant for recognizing, meant for using as a recognizing architectures. Okay, so they are completely deep learning network, and tomorrow we will be using that also. Like first we will be developing our own deep learning network, and then we'll be using ResNet or AlexNet in order to work on our data. Okay, and not on what they are like pre-trained on. Okay, so that is called the transfer learning model. So that also we will be discussing tomorrow. Yeah, you can use it, no doubt. You can use it because they are already optimized one, so you don't have to deal with the optimization with these networks. So for effective and fast development of deep learning model, you can use them, ResNet or AlexNet. I hope your doubt is clear, sir. Okay. Any other doubt from participants? Fine. So now we will move forward. Okay. So this is a kind of a confusion plot, which we generally see in a kind of a classification category. Okay, like here the case study is this. Like we want to detect like whether the person is walking, sitting, running, or dancing. Okay, so based upon whatever data set we have in spreadsheet or in terms of images. Okay, so as per the trained model, like how we check the accuracy. Okay, so to check the accuracy, we can have a confusion plot also, in which we can see like the diagonal elements will are directly proportional to the prediction and the accurate result. So the diagonal element should be as high as possible and close to 100%. Okay, for any trained model, close to 100% doesn't mean that it should be exactly 100. Just be close to 100%, because sometimes if it is exactly 100%, then there is a problem of like overfitting, which have to like take into consideration. Okay, so here we can see that in this confusion plot, the trained model has a confusion in recognizing a person between running and dancing. Okay, because these two activity requires fast movement of the body. Okay, so here the machine is having a little bit problem. So based upon this data, okay, we have to again go back to the data processing part, where we have to think of like what feature we can give it so that the machine won't find any trouble in understanding the running and dancing. Okay, so this is just a kind of a sample. Okay, so as we have discussed, the procedure for developing any machine learning model will be to first collect the data, and this one we have already discussed. Now, we will discuss some methods which are generally used for classification categories. Okay, the first method which we are discussing is a kind of a k-means, sorry, not k-means, a k-nearest method, KNN. In this, what happens? Assume that the picture which you are seeing, the graph which you are seeing, is having only two families, plus family and negative family. So what happens in KNN technique? If any third information you pass or a test information you pass, which is represented as a dot here, okay, red dot. So red dot is a test information which we want to see like in which category it belongs, whether it belongs to a plus family or a negative family. So here, whatever number you pass as a kind of a KNN technique, like 3, 2, 1. So 1 means it will check for the nearest first value, like to whom it is very close to it. So here, the distance between this one is called the Euclidean distance. Okay, the shortest distance between the dot to the nearest classified category. Okay, so here we have plus, so it will tell, okay, it belongs to a plus family. But the circle which encloses 3 plus dot, it means we are using KNN with 3 family comparison. So it will create a circle and it will try to accumulate the nearest 3 category or the already the outputs, and it will try to check, okay, like what is the majority case. So here the majority all are plus only, so it will give an output that this dot signifies to plus family. Okay, this red dot signifies to a plus family. Sir, why 100% is a problematic? Okay, yeah, good question, and let me show this one with example. So just wait, I'll first explain why 100% can be sometime be a problematic case. I'll go to Matlab. I'm taking a just dummy data, say 1, 2, 3, and 4. Just 4 amount of data. And y is equal to 1, 5, 8, 15, 40, or 15. CF tool and run this section. Okay. So now in this model, that is the curve fitting model, which we are already familiar with, I'll load X and Y. And yeah, so here by default, Matlab is fitting one straight line to it. Okay, what if so here I can see the adjusted R square, which should be 1, that represents to 100%. So right now it is 0.94, which is 94% accuracy. So if I increase the degree, okay, so now it is 96%. If I increase the degree to 3, then I have a value of exactly 1. Okay, right? So here you can see why I'm saying that sometimes it can be problematic, because imagine if this is related to an Ohm's experiment, okay, where actually it should fit to a straight line only, okay, but because in case of straight line we have seen that it is only validating to 94%, but if we fit a 3-dimensional polynomial, then that polynomial fit to 100%. So for anybody, like they will think, okay, like this model is better. But if we take this model, then we can see there is exponential rise, a kind of the rise is very steep after 4, okay, and below 1 it is very low. So if I generate this model, okay, and create a function out of it, generate function, generate code, okay, or better I will just assume this one. I'll directly code this thing and I'll try to feed a new value of x and try to check with like what value it will give as an output. So here the coefficient of p1 is 0.8. So we'll write all this coefficient and let me make the function only. Create, generate code. Yeah, generate code. Okay. Fit to, control S, save. Okay. Control C. Control V. And here I'll write coefficient, that is M, say. Okay, and run this section. Yeah. Sorry, not required. This one is not required. I'll put it into comment because now we have the function. I'll run this one. Okay, so now here we have all the coefficients. So taking this coefficient, I want to create what will be the value of y when x value is 10. Okay, so y value is equal to p1 into, so p1 I'll get it from m dot p1. Using m dot p1 will give me the value of p1, and this should be multiplied to x powers 3, right? X powers 3, then plus, can I copy this one? No, I cannot copy. Yeah, I cannot copy. So I have to write it manually only. M dot p2 multiply by x square, p3 multiply by, sorry, m dot p3 multiply by x plus p4. So m dot p4. Okay. Now imagine my value of x is equal to how much? Say it is 10. Okay. So in this model, let me take one more model also, and I will generate one more model also with linear model. Okay. And we will compare the result of these two. So this also I'll generate a code, and this I'll put linear. Okay, control S, save, in order to have a comparison. Control C, sorry. Control V, M only, and here also I'm going to calculate another value of, say, I put in YL, the linear value of Y, and here it will be M dot P1 into X plus M dot P2, right? And these two values will going to compare, like what can be the worst case of overfitting. And I'll run this section. Value is this one, where it is giving the error. Here it is giving the error, and why it is giving the error. Insufficient data. Oh, correct. Because I have changed the value of x. So let me create this one. Xx is equal to x. Duplicate this variable, and yy is equal to y. Just duplicating the variables, and this one it will become xx, and this one will become yy. Yeah, run the section. Okay, so now I can see the value of YL is 41, but in case of the cubic equation, it is giving 421. Now, this is the kind of a problem which we can get if we have like overfitted our network. Okay, it can give you abrupt signal, a kind of a spike it can give either upward or downward. So that is not possible. So that's why people most of the time they go for a linear trend. Okay, like linear or quadratic trend. Okay, good, but not for higher degree uh, polynomial trend, because it can have a fluctuation up and down. So here with the example, like as I said, if we are conducting an experiment with Ohm's law and we have only 4 observations, based upon it, I fit a linear model which has a efficiency of only 96%, and I fitted the same model with a cubic model. It has an efficiency of 100%, but 100% giving me a result at x is equal to 10, 421 compared to the linear one, which is 41. So this is the reason why we generally become a little bit more conscious when the result is giving 100%. I think, ma'am, now your problem is resolved. Neha Gupta, ma'am.
Sir, uh, but sir, like in this case, we knew that what's the relation. It should be linear, but
Correct, ma'am.
it could be a non-linear one, and we don't know then how to detect the uh, problem of overfitting.
How to detect the problem, ma'am? As I said, like it is not the always case. Like 100% can be result. There is a potential. Like if your neural network is giving 100%, then there is a chance that it can be like overfitting case, and that we will take one example in which we will be using a neural fit model. Okay, so with that model, I can have a highest efficiency with less number of neurons also, and with higher number of neurons also. So in that case, we will go for a low number of neurons, which is giving us the better result or the same output. Okay, so in that way, like because here we know the example, so just I wanted to correlate like how the things can go worse. Okay.
Okay, sir. Okay.
Yeah, ma'am. I'll come to that topic like when I'll come to neural fitting. So there I will discuss the optimization also, like how we can optimize the neural network, and there I will discuss you this case and with practical example.
Okay. Sure, sir. Thank you, sir.
Okay. So K-means is a type of a approach which we generally use in the classification also and regression model also. So in classification, like as I said, the unknown or the test sample is checked to which category it is like close to. Like in here, we have a it is close to plus, so it will give you output that it belongs to a plus family. Now, second case, here like we have with different parameter, say knn with one parameter, knn with two parameter, and knn with three parameters. Okay, so with one parameter we can easily see, okay, it will only bother about the first nearest family. Okay, so here it detected the negative, so it will give you output of a negative class. Okay, here there is a worst case, like it has both plus also and minus also. So then also your algorithm can again look for the lowest Euclidean distance. So in this case, again, it will give the weightage to negative. But the third case, if you look at, then here the majority case is plus. So here it won't give you negative as an output, rather it will give you positive as output, because it sees in majority it belong to a plus family. Okay, and if we imagine like a 45-degree line is there, then in that case also we can think, yeah, that is more somewhat case like it is on the border of negative and positive, right? So as you increase the parameter of the KNN, it will check with the entire population to which it is matching. Okay. Now, as said, the classification problem, that all the features in a neural network or training model, we call them instances also, or attributes also. Okay, so instance, attribute, and feature, they all mean the same thing. Okay, so based upon the attributes, okay, we have the output in terms of some categories like A, B, C. So there can be different sets of observation to which we can have the same category. This we will see with a practical example. And this is one example related to support vector machine, which generally used to classify between the two distinct categories. Okay, so it generally makes a line that divides the entire population into distinct two classes. One is below the line and one is can be above the line. Okay, so now we will do in practical and see how all this thing come into effect. Okay. So we'll start Matlab. Okay. Now, excuse me for 1 minute. I'll continue in 1 minute. Okay, so now we'll continue. So the first example we will see is of clustering problem. Okay, and after that we'll go for the supervised model. I'll delete all this, Control A, delete. Yeah. Clustering problem, and this will go under the unsupervised learning model. Unsupervised learning model. Okay. So first step, what we have to do, we have to load the data. Load the data. Okay. I'll do the code. So see, remember we have one flower family, okay, which has the output also. But imagine we want give the output to the model and try to see how the model without output is able to do the clustering, okay, and how effective it is. Say A is equal to read table flower .csv. Okay, we'll run this. Okay, and now we can see here we have the flower table where var1, var2, var3, var4, and the variable 5. So variable 5 we don't want because that is the categorical data and that is the output also of all these feature or instances or attributes. Okay, so we'll create a duplicate table which will only contain, and we have to convert data from table into array. Okay, it should be matrix data for a clustering problem. Okay, So here I'll write on comment only, convert table data to matrix. Now here we're going to convert it using, say, b is equal to table to array command, and this will take all the element from A, take all the row because row are the observations, and in column I'm only interested from first four columns because first four are the features or attributes. Fifth column I reject it, and now if I run this one, so now I have a matrix having all the features: petal length, sepal length, ratio, all the same. Now this I want to feed into a cluster problem. So I'll divide the screen. For clustering problem, we'll go to the app section, and in app section we have to go to the machine learning and deep learning model, and there you'll find one neural net clustering. Okay, so this toolbox will going to open. Okay, or you can simply type nc tool also in the command terminal. In both way it will launch. So here also if I type nc tool, it will launch the cluster neural network toolbox and run it. It will going to launch. Okay, so we have to click on the next, and here it will ask you like what input we want to give it. So the input is into the form of B. Okay, because in B matrix we have stored the flower data and just the feature, not the output. So B, and now it will ask you whether that matrix is a column or a row. It means here that where you have kept the observation. So here in our case, the observation is in row wise, okay, not in column wise. So I have to change it from by default column to row matrix because I have 150 observation, and each and first 50 for one category of flower and next 50 for other and last 50 for other. Okay, so that I know, but this machine don't know that thing. So matrix row we have set, and now we will click next. Size of two-dimensional mapping. Now here it will ask you to give the dimension of the size in which Matlab will going to create the clusters. Okay, so if I give a size of 2, then Matlab will create a 2 by 2 matrix, and in this 2 by 2 matrix, so the total output will be 4. Okay, so in 4 lumps it will try to fit all the population, and let's see what is the output. So it is creating a network here, and now we'll click on the train option. Okay, so training complete, and now if I want to see the samples, then I'll click on the plot sample. So here I can see it gives me the visual distribution of the entire population. So it says that in the entire population of data set, there are 50 data set which are very close to each other, and then there are 40 which are close to each other, and then we have some separation. We have again 28 which belongs to some population, and 32. So it gives a four segmentation of the entire data set. Okay, now see if I want to change it, and these are other different methods, say neighbor method, in which what happens, like the purple color represents your data population. So the in between color which you are seeing as red, yellow, black, all these things, so the dark intensity color represents the separation, like how much that from that population this population is different. Okay, so here we have black color. It means the data which is there in the first quadrant, okay, and compared to the data in the third quadrant, they entirely different from each other. They hardly share any features. Okay, and the yellow color means they are very closely to each other. So whatever third quadrant we have data, it is also close, have a close relationship with the this one, the below. hexagonal data. Okay, so this way it gives a color resemblance for a psychological understanding of the data. Now say I click on back, and this time I give even more segment distribution, that is 3 by 3, that is in total 9. I want to see how much population is distributed, and click on train. Yeah, the training is complete. Now I can click on plot sample plots, and here also I can see again there are 50 population which are very close to each other, and rest it is divided into this category, in which there is one category which we can see there is no element. It means we have a quite separation from the other population. So this market segment is very much sharing the common properties compared to the other market segment. So this way it can distribute the entire population into the lumps of categories. Value of k, that too depend upon your analysis, like at what value of k you are getting the good result. So that is it's not any thumb rule. You only have to iterate and check like how much it has accuracy with your output. Accordingly you can get that information. It is best, it is based on test data. Yes, it is based on test data, test and train data both, because the overall efficiency of any model is dependent upon the training model also, and the data type also, like what kind of data base you are providing. Did it contain the variation also in it, or just a simple same amount of data only you are replicating it and giving it? Say if I take example of a, say dog face versus cat face, okay, then a person can give data just taking the front view of the dog face and cat face. But what if somebody gives the side view of that dog and he pass into the network? Will the network will be able to perform in that case? Because we haven't trained the network on these varieties. So while creating a model, we have to keep in mind that we should provide a variety of data to it. Okay, so that way it totally depend like how you are training your model. Anyways, so discussing again to the clustering problem. So this is how Matlab able to cluster it. Okay, so any problem up to here in understanding how we can cluster? Okay, yeah, code, don't worry. Code, I will share it. I'll convert in every session, I'll convert the code into PDF and I share it on the group only. Is this same as number of clustering? Yeah, number clustering also you can do with this approach. How to find the number of clustering to be, how to find the number of clusters to be formed? Okay, yeah, that is a very good question. Like it totally depend upon you again. Okay, because what happened, machine exactly don't know like how many numbers should be adequate. So what we do, we go for a lower number to higher number. Okay, say suppose I'm a businessman and I'm only want to invest, okay, my money into a particular segment which has a highest population. So while doing all this analysis, I come to know, okay, there are 50 people, sorry, not 50 people, there are a major chunk of the population is there who share the most common feature. Okay, and instead of focusing on the 4th and 11th and 12th hexagon, I'll focus my attention in giving my service to the bigger quadrant, okay, which is having lot many people. Okay, so in that way, I'll start from say 2 by 2, 3 by 3, 4 by 4 analysis, and I will see, okay, in all these cases, how the entire population is defragmenting it into their various uh, features or behaviors response. Okay, Quickly revise, please. Okay. So here we have first discussed the unsupervised learning model using clustering. Okay, as I said, unsupervised learning, we generally do the clustering. Okay, like in clustering, what kind of problem we can deal? Say suppose we have a data set of customer buying. Okay, what items they buy. Okay, now if I have those data, again my model can cluster what kind of item people generally buy, either that is related to food item or some clothing or some electronics. Okay, but computer don't know like whether your data is related or like whatever cluster that is, it is related to food only or what. It will just cluster the population into some lumps. Okay, and it will give you, but once it gives you that lump, you can easily recognize, okay, what kind of feature it is. So many times some people have asked like, do clustering or unsupervised learning can be helpful in supervised learning? The answer is yes. Okay, because the output of the unsupervised learning model, you can put it into a supervised learning model as a kind of an input or first step. Okay, in knowing the features. Say suppose I have divided the entire population into 4 categories, so it means I have to derive only 4 feature out of it. Okay, so like that way also we can mentally come up with a, and it only purely depend upon the case like which you are dealing with, how we can divide the test and train. uh, Ma'am, here we are not dealing with those test and train. Here it is a clustering problem. Test and train are only applicable in those cases where you have the output also. Okay, here we just have input. Here we don't have any output. Okay, so in supervised learning, we deal with the test and train because we have some output with respect to which I can see that whether my network is performing right or not. Okay, but here because we don't know the output, so there is no meaning of this thing. Test, just a train is there which will only just as per the k nearest method algorithm, it will be just lumping it. Uh, Read table and XLS read both are working to read the CSV file. Correct, sir. But if you are using XLS read, then XLS read won't be including the output, which is in string format. Okay. But if you take a read table command, then it will take not only number data, it will take string data also and date time also. So if you have a larger database, then you can take having like different varieties of data type, then better recommended use read table instead of XLS read. Finding the value of k is a trial and error, a kind of a, yes, until we find uh, the accuracy, in which case it is related to what we expecting is same or not. It's a kind of a trial and error only. Like we don't know like which k value will give the highest efficiency, so we have to test it, and in MATLAB we have a toolbox which does automatically for us. CSV file can be loaded by both syntax. Yes, it can be loaded by both the syntax. Okay, how to use NC tool? Please review some in 2 minutes. Okay. So as I said, to use the NC tool, you first have to make your data in terms of matrices. Okay, and in matrices, the data or the observations, okay, can be arranged in column wise or they can be arranged in row wise. It is up to you. Like in our case, the observations are in row wise, okay, and the features are in column wise. So we have a total 150 observation having 4 feature of a flower experiment, okay, in which the first column represents the sepal, the second column represents the petal length, and the other one are the ratios. Okay, so I have used the read table command because read table have a different data type. So I have to convert read table into a array. But if you are using XLS read, then you don't have to do any conversion because XLS read by default exclude the string data. So it will be in matrix only. So once you have loaded the data into matrix format, just type NC tool and it will and run the command and it will activate the clustering toolbox in MATLAB. And here you just have to click to next, load the data which we have stored into B variable. As we can see here, like B is having the matrix data because A is having the table data. So we'll put B, and here it will give you two options, like whether you want to do column or matrix. So because our problem is having all observation in row, so we'll put in row and click next. And here it will ask you what is the dimension of square matrix you want to segment the entire population. So I'll go for the lowest one first and see like how the population is behaving. Okay, so I give 2, and then I'll check for the 3 also and 4 also. So in 2 the training happens within a second, and I'll hit on plot sample hits to see the population distribution. Now same thing, if I go back and change it to 3 by 3, which is 9 population distribution, there I can see that again there are still 50 population which are very close to each other, and rest the other share some properties. That's why they like distributed into different lumps. So it is total 9 quadrants which you are seeing on your screen. Okay, some key value give good 10 result, 10 value, and for the 11th it may not. How to solve this problem? Again, ma'am, there is no thumb rule like what value of k you should be using in order to get the highest efficiency, because as I have discussed in this image, okay, like if you are including major population, then maybe there can be a good scenario in which majority of the population will tell, okay, how close the test point, which is denoted by cross symbol here, okay, and the dotted area which is enclosing all those the value of k, okay, like in the last case which we have 3. So 3 population, it is like correlating and testing like what is the majority here. So if you are enclosing more and more, then majority decision will be given to you, and it will be like more right in terms of majority decision. Sir, can you show the accuracy value? Which accuracy value? Santosh sir, which accuracy value you are asking?
Sir, that model, that data set we were classified, na, sir, that accuracy, classification accuracy.
Sir, see, why can't we have an accuracy here? Correct. So this is a clustering problem. You are correlating this with the classification problem where you have an accuracy in terms of accuracy or RMSE. Here there is no accuracy. Why there is no accuracy? Term is involved. See, to know the accuracy, to know whether I'm right or wrong, I should have to know the result, right? If there is no result at all, I cannot compare it. As I said, that we have removed the output. Okay, but yes, if I compare this thing with the output, which I know that only 3 classes are only there. Okay, but instead of 3, I want Matlab to distribute the entire population into 9 segments. So in terms of 9 segment, it will like a kind of a meaningless. But I just want to see like how the population are closely resembled to each other. So
then, sir, in this unsupervised technique, then how we can compare that our model is the best model in comparable to other models results? Which
no, sir.
parameter we need to comparison, sir? Result part.
Okay. Okay. We will take this as an example. If I ask from you, how many types of plant are there on this earth? What will be the answer? Can anybody give me a right answer? how many types of plant are there on this earth?
In the data set, or sir, in
No, if I give you like data set also, and in general, I'm asking like how many types of plant are there on this earth, then can anybody give me a accurate answer? Or if somebody says 2 or 3 or 100 also, then also I cannot correlate because I too myself also I don't know the answer, right? Okay. So clustering, you have to understand that clustering deals with that problem only where the person and even the computer don't know, okay, what is the actual output. Rather, it takes the information from you that what you want, and say you give, okay, take my data set and I want you to segment the entire population into 3 cluster or say 4 cluster, and it is left to you like how you do. So what MATLAB here is doing, based upon the values, the feature we have provided, okay, and it will going to create the clusters in 4 cluster. It means it is putting those species of plant which share similar properties, okay, like the plant which are like grown in the desert area, they have a different length of the leaves, okay, the color is different. So based upon all this color, length of leaf, it will put the entire population into those lumps, because it is asking from you only like in how many cluster I have to keep the data. Okay, can we label the cluster? Yes, we can label the cluster. So instead of using NC toolbox, I think it is like making a little bit confusion here. I will use a different clustering approach using command algorithm instead of using any this thing toolbox, and then I will show you how we can correlate this thing. So I will use Kmeans cluster, okay, technique, say IDX. So IDX here contains the categorical name. Okay. So let me first complete this command and then I'll show you IDX and see the centroid coordinate. See K-means cluster. So I'm using a K-means cluster. So the moment I type K-means, to come, MATLAB is showing you can apply K-means clustering technique. So we know that K-means clustering is what? It just uh, shares all the spatial distribution, and with respect to the mean centroid calculated as per the number of parameter we are passing. Say suppose I pass 3 parameter. So there MATLAB will create 3 centroids, and each centroid it will check like should have more population close to it. So K means, and I pass the B table, and here because I know that the parent database contain only 3 family of flower, okay, so if I pass 3 here, okay, so here MATLAB will divide the entire population into 3 families only, okay, with the name 1 2 3, okay, and now I'll run this code, and now you can see here. So as I said, IDX contain the name of the family and with a number. Okay. So MATLAB won't give you like the name of the flower. Okay, it belongs to a Satosa family or versicolor family. No, it will just give you a number family. Okay. So it tells here, or let me take it out so that I can show it on the screen, what this table data contains. Okay. It contains the data as per the sequence of the table. So let me bring it out and show you. Take out. Okay, I'll tap it here till it load IDX. Okay, so here, if you look at to my command terminal, I just type the value IDX, and here I can see there are all the output is written 2 to 2. So first 50 is nearly about 2, and then there is 1 3 and then 1. Because why it is showing 1 to 3? Because I only told MATLAB that it has to create only 3 family. So all those observation which comes under family 1, they will be labeled as 1. Okay, and all such observation which are close to the family of 2, it will label it 2. Okay, so that's why we can see here 1 2 3, and in between I can see a third family here, because I know my data is shorted out. So first 50 only belongs to particular family, the next 50 belongs to some other family, and the last 50 belongs to other family. Okay, So the in between which you are seeing a different number, it shows that there in that species there is a plant which has a very similar feature of the other family also. Okay. So when we will be using classification model in the next half session, so there also we will see there will be some confusions. Okay, like in the confusion plot. So now what I will do, I'll combine this information, okay, and put it into a categorical data. Okay, like as somebody asked, like can we put the result into a categorical data? The answer is yes, and we can label it also. So here I'm using a numeric label, say 1, 2, 3. Okay, and before doing that, let me change the number from 3. Instead, I will use 5. Okay, so now Matlab will create 5 different family. Okay, and in this family only it will try to fit all the population. And let's run this and check. So now if I run idx in the window, so now you can see the same result. Okay, so as what we are seeing in the NC tool, that there are first 50 which belong to a particular family. So here also in Matlab also we can see there are first 50 which is giving to a family named 2. Okay, and after that we have 1, 3, and 3 again. Sorry, yeah. First 50 is there, then 5 and 2. So a combination is there because now I have distributed the same population into 5 categories. So it gives me an idea, okay, to what number I can go and have a majority of population. Okay. So now let me add this one into a combined table. So how I can create a table out of it? So I will create a new variable, and in this variable I'll add the data of B, and in the second column I will put the address of category or categorical data I'll put, but right now it is just a number, not a categorical, so I have to convert it into a categorical data. So let me see. Okay, I'll full screen it and I'll do it here only. Say tab is equal to, because it is matrix data right now, so I have to use array to table command in order to convert into tabular data, because in table only I can store categorical data. In matrix I cannot store a categorical data. Okay, so I'll use new, that this I have to convert it, and I want to use variable name as per my this thing. So variable names, and because here they are cell data, so I have to give variable name in quotes. Say I give sepal length. I'm giving the name also this time. Sepal length. This one I'm GTH sepal length. Then with comma and 3 dots, I'll continue my line from the next line. Petal length. Sap ratio. Petal ratio. Pet ratio. And my final output. Okay, so if I run this command, it will transform and create a new table having name as per my command. Okay, sepal length, petal length, sap ratio, pet ratio, and the last I have the output, which are 2, 5, and based upon like what number I have used in the Kmeans clustering technique. Okay, now I want to make the last output because it is a number data. So how we can just justify this one? See, if I go to my command window, okay, and tab, the name is tab, control C. Yeah. So if I write here, say home, control V, tab dot output, and I'll call say fifth position. What is the output? It gives 2. So if I add this one to the same, it will do numerical computation. So it means it is not a categorical data. So what I have to do, I have to write it like this. Output is equal to categorical, or better I will do it here only, so that later on I can give the PDF to all participants. So I have to write it like this, tab dot output. So I'll take output is equal to, in order to convert it into categorical, you just have to write categorical only, categorical, yeah, this function, and it will convert the entire data into categorical data. Output. Okay. Now if I run this one, now I have the last data as categorical, but you won't feel any difference by visual. But if we do the same computation now we will see one difference. If I pass the same value 5, now Matlab is giving that it is a categorical and category it belongs to 1. Okay, and same if I take another say 100 element or 101 element, okay, it belongs to category 5. So in this way I can even short it out the entire population and see the visual. Okay, so I'll put it into 3, and now I'll make a graph, okay, in which I can see like how the entire population will look like in a spatial distribution based upon the categories, okay, which with Kmeans clustering, because that feature we cannot deploy in the NC toolbox because they are not giving that feature to implement code it, but with the help of coding we can do whatever we want. So here, now what I will do, right now what I have done, I have used K-means clustering in order to divide the entire population into 3 families. Okay, so each family will be having output either 1, 2 or 3. Okay, so we can see here in the table that this way the entire population will be shown. Okay, now how to plot the graph? Okay, so first I will use hold on command because multiple graph I have to plot that depend upon the number of k-means. So there are 3 families, so 3 graph I have to make it superimposed on the same graph. So that's why hold on and hold off also, all right. Yeah. Okay. Now I'll use plot command. Plot. I'll use find function in order to note at what position the IDX value is, say IDX value is equal to say 1, and this position will be plotted against new t, which is our table, and from this new t also I want to take only those data whose last column, which is our output, that is equal to, so last column is at 5th, so 5th one data is equals to same, say 1, and this bracket goes to here, yeah, okay, and then I'll make it a, say I want to plot it with a red color with O kind of a marker. Okay, so first I'll run this one. Okay, so now I can see a spatial distribution. Now I'll use this same line and change just the value of family name, and I will see the plot. So in this case I'll plot the family 2 with say green color instead of this, and this one here I will plot family 3 with blue color. Okay, and I'll plot the entire graph. Okay, so now you can see in this section how Matlab is able to lump all the cluster, okay, and why in some cases it is showing the other result. That also we can have a better look. So now I'll just zoom this. Okay, I think it won't be visible. I'll increase the line width also so that it will be like very much visible. Line width to say 5. So this one also I'll include. Control C, Control V. Okay, now I'll run this. Okay, yeah, better. Okay, so now we can see the spatial distribution of first family, which is green, second family, which is red, and the third family, which is blue. Okay, and if I change the value of k, then again I have to change the value of the plots also, but directly depend upon the value of k only. So if I use 5, then I have to use 5 number of plots also to see the different colors of the family distribution.
Sir, what are x and y axis here?
Okay, so the x-axis are the observation numbers. Okay, like here we have, because 150 data, so the data which is at say 51, if we take a data cursor. Okay, data cursor, yeah, data type. Okay, so if I say pay attention toward this point, then it says that the data which is at row number 51, okay, it belongs to a blue family, which is third family. So this x-axis belongs to the number of observation or the indices of the observation. So for each observation we have the value which is the by default the first feature. The first feature in our case is the, I think, sepal length. I think it is the sepal length. Yeah, this sepal length. So against the sepal length, we are getting the view.
Okay.
Okay.
So that we should have 5 such figures to correctly visualize the.
Pardon, sir?
So since we are having 5 features,
Okay.
so should not we have 5 such figures to correctly visualize the things?
Sir, your voice is not coming properly, but I can guess what you are trying to say. Yeah, because we are comparing right now the graph with the number of observation with the first feature. Similarly, we can have a graphical figure in which we can compare with the number of observation with the second feature, then third feature. So like that we can do. Yes, because it is a 4-dimension problem, so I cannot have a plot because in 3D I can have only 3 dimension, but here the total number of observation is 4, which represents a 4D problem. So I'm making a plot in 2D, taking one feature at a time with the number of observation.
Okay.
Okay, now I'll take a 5-minute break, not 5 minutes, just a 3-minute break, and then I'll continue with the doubts. Meanwhile, I'll put this code on the screen. Okay, yeah. So the entire code. Okay, yeah, now we'll continue. Kindly repeat the code once. Okay. Okay, first I'll make it a proper documentation. So here I have used Kmeans clustering instead of NC tools, but I'll include NC tools also so that the participant can experiment. So and these NC tools will be used for uh, neural clustering toolbox. Okay. So in line number 1, we have included data which was having the number also and string also. So we have included the data into read table, and after that we have just extracted the feature information. We have excluded the output which was under the string. Let me show it here. Yeah. So as we can see in A, we have total 5 column, out of which the 5th column contains the name of the family of the flower. Okay. So first 4 is the feature. So I have extracted the feature information and put it into a matrix B using a table to array command, which converts table data to matrix. And this, after that, I have used NC tool, which we have checked also, like how to work with a neural clustering toolbox. Once again, I'll repeat it. I'll just run this section. Neural clustering toolbox, you just have to feed the information, like B is the matrix which I want to do, because in my case the observation are in row format. So I'll click on the matrix row and I'll wait till it shows the next button. Yeah, and here you have to give the square matrix size in which you want to fragment your entire population. So I can give any whatever I want, say 3 this time, and I'll click on run algorithm, which they have put it as a train algorithm, and plot as sample. I'll click on it and it will give me the plot of the entire output, that in 3 by 3, that is 9 column. What is the output? I think output is already there. It is here only. Yeah. So each purple color hexagon represents like how many population from the entire population belongs to this cluster. Okay, so here also we can see there are still 50 population which are so much unique that they belong to a particular cluster only, with respect to the other which get defragment into smaller population if we increase the number of defragmentation. So that is the ANSI tool method.
And sir, what are X and Y in this figure?
In a neural clustering X and Y, you are asking?
Sir, what are X and Y in this figure?
Okay, let me run it once again then. Okay, the X and Y data is a just kind of a normalized data between this one -1 and this thing, but here it do not have any significance like what is there. Okay, because all the data has been put into hexagon and the number inside the hexagon has a physical meaning. That is the significance of the feature which we are sharing. That's why MATLAB do not write anything like what is there in the x-axis and y-axis, just a number, spatial number distribution is there. Maybe a kind of a normalization technique it is using for all the rows and like all the column information in order to put it into cluster.
Okay, and it gives the title as hits.
Hit, okay, hits sample. Yeah, see, actually, when you train the model, it will give you 4 types of output. So in sample hit, it generally give you the number of population that are there in the cluster, and in the sample neighbor distance, it will give you the same output but with a color representation. Okay, like where dark intensity represents the separation. The more darker the color, the more different behavior the neighbor cluster share with each other, and the lighter the color, the more close they are with each other. Okay, so sometimes we require both the information also. Okay, so is my sound is coming low?
Yeah,
Other
no, it's
participants?
okay, okay.
It's okay, na? Yeah. Okay. Yeah. So after that, because in that toolbox, I cannot know like which population, though it tell me, okay, like this much population belong to this cluster. But I want to know like what are those population that belong to which cluster. So I used a k-means clustering function so that the output of this k-means clustering will be stored in 2 variables. The first is the identity of that population, which it will assign the categorical value. So here, because I want to divide the entire population into 3 families, so it will assign the family 1, family 2, family 3 name to the entire population based upon their features. Okay, so first 50 we know that it will belong to 2, so here it is 2 only, and the next 50 should be 1, but here are few species because they have a close relationship with the last family also. So based upon the k nearest method, it checks, okay, like if it has a more close relation with the third family, it will show it is belong to third family only. Okay, so these are errors. It is very obvious also, that we will see in confusion plot also when we'll be doing classification problem under supervised learning, that there also machine will have some difficulty in understanding some observation. So that is a normal thing, but the good thing is that now we are come to know, okay, which population, the population at observation number 51, it belonged to a separate family. So this information we required in order for the, say, next step if you go for the supervised learning or the other model. Okay,
So
so
what is
that
C
way,
here? IDX C? C?
okay, C is the centroid of the entire observation. Say the first observation is of sepal length, right? I think, yeah. So here the first variable which we have given the name as a sepal length. So the entire centroid of this column data. So it is 5.9. See, actually what happens, because as I said, we have divided the entire population into 3 family, right? So you imagine 3 family as a 3 hexagonal cluster. So each cluster will have its own centroid coordinate, right? So the first family is having the centroid. Okay, so based upon its centroid location, so at what location of sepal length it will come, at what location of petal length it will come, at what location of sepal ratio it will come, and at what length of petal ratio it will come. So all these 3 sets you will going to see.
Excuse me, sir. Hello.
Okay, okay. Hello. Yes, ma'am.
Yeah, sir. So like we are having 3 rows. That means each centroid is related to each family.
Correct, ma'am. Each row
Okay.
belongs to, like the first one gives the information about this. Wait, 1 minute, I will show you. So first family belongs to, I guess, it is 2. So first centroid gives you the address of second family, okay, which is named as 2. And the second row here, because majority is 1, so it gives you the family information 1, the centroid location. And similarly, the last one is our 3. So the last gives the information about the third one, because the majority element in that is 3. So hello.
So is it necessary to consider centroid as the measure? I mean, can we consider any other measure instead of
Yeah, ma'am.
centroid?
Yeah, ma'am. There are other method also, because we are using K-means clustering technique. So the algorithm requires, like, first it calculates the centroid, and as per the centroid, it gives the classification name. Okay. So if you are using some other clustering technique, say spectral cluster, there you will have a different this thing. Calculation of centroid, like, method will be different. Okay, like, let me show you. Instead of k-means, imagine if I use control C, if I use a different clustering technique, say I make it id double x and instead of c, double c. Okay, so the output will be different. Say spectral cluster, spectral cluster. Yeah, we have a spectral cluster also, and here also we have to give the same information. What is the population, and in what lump or categories we want to distribute. So here also I give 3. So here also it will give you 1, 2, 3 as a family name, and we will see, compare the output of these two. Okay, and because here you know the output, so you can calculate the accuracy or efficiency, because you already know the output. But as I said, like, most of the time when we do unclustering unsupervised learning problem, we don't know the output, so there we face the difficulty in knowing the efficiency. Okay, so I'll run this section. Okay, not required. So here you can see we have id double x and cc. So what I will do, I'll take out the idx element and I'll compare it with the k-means output. So here I'm comparing, or better, I will write a command which will do this thing for me. So see, if the value is same, I assign it 1, and if the value is differ, okay, and I will assign 0 at that point. So I'll make a logical operator here. Say result is a logical operator, and what this operator will hold, if the idx value is equal to id double x, okay, so this value it will have, and I'll run the entire this thing, putting this one in comment. Run. Okay, id double x result, where is result? So here is the result. Okay, now let me sum this result to get the value, like how many times it is giving us the accurate result and how much time it is differ, and that's why I can calculate the efficiency also. But let's see the sum first. Result and stop. 1 minute. Stop. Okay, well, id double x and idx.
So basically it is showing only 2 times the categories are different because we have assigned 0 when the categories are different.
Correct. So we can see that the spectral, whatever it is assigning, oh, it can see here. The problem can be this: maybe in spectral, the first family name, the spectral analysis, it is assigning a different value, say 2. Okay, but here we are not concerned with the value 1 or 2 also. Rather, we are more interested that the values should be same. So in IDX, if it is 2, 2, so up to 50 times, if it is 2, and in spectral also, if it is 1 up to 50 times, then it is same, right? Because the name assignment can randomly change, right? Are you getting this concept? That we
Yes, sir.
cannot
Yes,
use
sir.
this method in order to compute this one, because randomly it can assign the family name to 1 also, the first family name, or to 3 also, the first family name. And this is what is
Yes.
happening when we are using. So this is not the right way of comparing these two. Rather, we have to write a different algo in which we have to check for the first 50. So what is that first 50? Whether it is 2, so we have to compare that one with this one. So like 3-4 lines we have to again write it in order to have a good comparison. Okay.
So can we make all these variables categorical? So ultimately they'll assign 1, 2, 3 and 1, 2, 3 for both the cases, and then we can compare.
Yes, you can do anything. Like once we did it for this, so we can replace 1 with a categorical name, say flower 1, okay, 2 with the flower 2, and 3 with the flower 3, and same we can do with the other part also, okay. And after that we can do the comparison, like whatever first 50 is there, based upon the majority number, we will assign a particular name to it, and this way we can do the string comparison rather than number comparison.
So my question is, can we directly compare the categorical variables? Like suppose we using k-means clustering, we get
Mm-hmm.
values for the families as 1, 2, 3. Okay,
Correct.
and use
Correct.
spectral cluster, we are getting values as 2, 3, 1 for the same three
Correct.
families.
Correct. Correct.
So if we convert these two variables in categorical variables, so
Mm-hmm.
ultimately they convert to 1, 2, 3 and 1, 2, 3.
No, ma'am.
It won't change as 1, 2, 3 because when you
No.
changed uh,
No. See, ma'am, when you convert a categorical this thing, only the data type is changed. One will be remain categorical 1 only, and 2 will remain categorical 2 only. Okay. MATLAB don't understand, okay, what this one like belong to this family. Okay. So there, that's why I told you, you first have to analyze what is the majority name to it. If it is 1, then you better give it a suitable name, say alpha. Okay. And in the next 50, if it is 2 or 3, you give it a name beta. Okay. So this, if you do on the other spectral also, which is randomly giving the number to the family, say 2, 3, 1. So that way you are deducing all this number information to a more clear common name, that is alpha, beta, gamma. Okay. But if you directly
okay.
convert into categorical, then it will be categorical 1 versus comparing with the categorical 2, and MATLAB will give you 0 there also. Okay.
Sir, but like when you showed the example of changing to categorical variable in
Correct.
the not in the live script but in that main window, so
Okay.
there I guess when you click for element 5, the
Mm-hmm.
values changed. Like at first it was showing 2 when it was not a categorical variable, and after
Mm-hmm.
converting the to categorical variable, it changed to 0 if I remember correctly.
No, no,
So
no, ma'am.
uh,
Actually, I changed the
0
indices. I'll
1.
show it once again. Don't worry, ma'am. I'll show it once again because it is a confusion, and I won't let any confusion. See, I'll do it once again. I'll put
Okay, sir.
because the data is already there here. So what I will do, uh, IDX. First, I'll run the IDX, and you can see here the IDX data is this, right? Okay. Now, as I told you that we can convert categorical using a categorical keyword. So I put, say, alpha is equal to categorical, or better, I will use home command so that all participants can see. So alpha is equal to categorical of IDX. Okay. So now alpha will contain the categorical data of IDX, right? and here we have. So now you can see here. So now here I have the categorical data of alpha, correct? And if you compare with
Okay.
IDX, the IDX value is also 2, and in categorical also it is 2. But yes, now if I call alpha, now Matlab will not do any numerical computation because it is categorical data. Okay. If I pass alpha 5 and I will add with alpha 3, it won't going to do any numerical computation. Why? Because it is categorical data. But same I can do with IDX because it is a numeric data. Say 5 IDX plus IDX 3. Same thing, I can do it here, but I cannot do with the alpha because alpha is a categorical. So the value won't be changed, rather the data type will be changed. And that you can see here on the workspace also. If I double click, the matrix symbol is changed and it is put into 3 circles, which is categorical. So if I double click here, the Matlab here you can see it is categorical and the data is still same, but it doesn't matter, but the data type is changed and compared to IDX. So all value is same. If you can see it here, it is same only, just the data type is changed.
Okay, sir. I thought the values will change. Somehow I
No,
got
no.
this values will change as well. Okay, sir. The confusion is clear now.
Okay.